Okay, welcome back. Okay, we're working on section 5.1 in Intermediate Algebra, Martingale, 4th edition. And I looked over this section. Honestly, it seems like this is material that we've already done. But let's just get into it and see what it's all about. We'll do the even numbers. First it says find the degree of each term. Okay? So we start off with number 2. The term is 7, so we got a thunderstorm going on. You might hear the rain or the thunder. 7. Well, you might, the way to look at see what the term would be is if this is the same as 7x to the 0 power. In other words, this is a so-called 0th order term, which would be a constant. If you had a quadratic equation, there's going to be a second order term, a first order term, and then there'd be the so-called 0th order term. Now, 0 doesn't actually show up because x to the 0 is 1. But the answer to that question is 0. Okay. Now we'll do the next one, negative z cubed. The assumption here is that z is a variable. Okay, and this would be the third order because there's a 3 in the exponent, so it's quite easy. Number 6 is 12 x cubed times z. Now, this is third order in x, and it's first order in z. Assuming that x is the unknown and that z is known, this would only be the third order. But for the purposes of this exercise, anything that's in the form of a letter, we're going to assume is an unknown. So we're going to assume that the x and the y and the z are unknown. Now, if it has something like an a or a b, sometimes that's understood also to be an unknown, but sometimes that can be understood just to be something called a constant. So let me see if I can find an example. In here, where they use a constant, something, let's see, I don't see an example, but I think they're going to throw out as an example because I saw one. It turns only a number. It's called a constant term. Simply a constant. X, y, and z are always reserved generally for variables. Simplify each polynomial. But I can see here that what I can make out, any letters such as A, B, and C are also considered to be variables. Okay. I just wanted to make sure that I didn't overlook an example, because sometimes in cases like this, there's no absolutely correct answer. It's a question of interpretation of what you're doing. So let's continue. This is, I'm going to say, is fourth order because the total number of the exponents on the unknowns are fourth order. So for example, and the reason for that is, if you had, let me give you an example now. If you had something like x plus z raised to the 4th power, and you expanded all of the terms out here on a binomial expansion, there would be one term that looked like x cubed z, because of the way that if you multiply out all the possible combinations, x plus z to the 4th is x plus z times x plus z times x plus z times x plus z. And if you use the distributive property repeatedly over and over, for example, this first one here becomes x squared plus 2xz plus z squared. The second one would also give you x squared plus 2xz plus z squared. And if you multiplied all these out, you get 9 terms Because each one of these multiplied by each of these gives you 3 terms. Each one of these multiplied by each of these gives you 3 terms. So you get 3, 3, and 3, 9 different terms. Each one has a different, each term will have an x and a z in it, and each one will have a different exponent for the x and for the z, but the sum of them will always equal 4. And that's because of the original 4th order term. So in this case, for example, this term here times this term here is going to be 2x cubed z. Okay, this is exactly of this shape. Now it turns out that this term here times this term will also produce one that's exactly like that. So that's why, even though there's going to be 9 terms, some of them are going to be identical, and they will compress into a smaller number of terms. You might end up with only 6 terms at the end. But the important thing here we're trying to get at is simply to get an understanding of why they're talking about this as the order of this term. Okay? The rule is quite simple. You just add the exponents. But I'm trying to provide you with a little bit of explanation for why that's useful. Okay, next one. Minus 9 to the 11 times y to the 5th. And this is the 5th order because this 9 is not a variable. It's just a number. It just happens to be expressed as in an exponential form. So the answer is 5. 9.1 times r squared s t to the 12th. So in this case, we're considering r, s, and t to all be variables, not constants, but unknown quantities. And therefore, we're going to add these up, and this is actually going to be, this term is up to 15th power. It's a 15th order term. So yes, the degree is 15. Also called the order. Okay. Let's move on to number 12. Find the degree of each polynomial and indicate whether the polynomial is a monomial, a binomial, a trinomial, or none. So this one says 7x minus 0.8. Well, first of all, this is a binomial because it contains 2 terms. Okay? And this is a first order. And the first order is because the term that of the 2 terms, the one with the highest order is what you use when you say what is the order of the entire binomial. So since one term is of 0th degree and the other one is of a 1st degree, so the entire binomial is said to be of degree 1. Okay, so that's of degree 1. And the second example, the next problem is 5x squared minus 3x minus 2. Well, this is a trinomial because there's 3 terms. And this has degree 2, or also called a second order trinomial, because the degree of the highest the term with the highest degree is 5x squared, and the degree is 2. So this is called second degree or second order trinomial. Also could simply be called a polynomial. Okay, next one is minus 7 to the 5th, a, b, and c. Okay, this we're going to call third order because this is a to the 1, b to the 1, c to the 1, and here a, b, and c are considered to be unknowns. Okay, third order, and it's a monomial. Okay, this is just what you call nomenclature. Nomenclature, it's not really very mathematical, it's just a definition of terms, but it's done for a reason, so it is useful to learn. Okay, the next one is negative 2x squared y minus 3y squared plus 4x plus y to the 5th. Okay, the term with the highest order is y to the 5th, and the degree is 5. I have a habit of calling that order. I keep finding myself saying it over and over again. And they're calling that degree in this chapter, but it's the same thing. That's the 5th degree. Okay. Number 20, it says simplify each polynomial by combining like terms. Okay. And we've already been doing this on all of the homework assignments that we've already been doing up to this point. So I'm a little surprised about why they're actually asking us to do this now, as if we didn't already know how to do this. Okay? The idea here is 3x and negative x is 2x. Negative 4 and negative 9 is negative 13x squared. Okay? And I've already been using this as if this were obvious. This is the distributive property. Negative x plus 3x is equal to x times negative 1 plus 3. You can factor out the x, but nobody really does that. They just know that if you have an x, a negative 1x and a negative 3x, you're going to add them together, and you're going to end up with 2, right? Okay. Now, 22. Negative 8x y squared plus 4x minus x plus 2x squared, 2xy squared, minus 11/15. Okay, now, like terms, what do we see? There's a 4x, so that's going to be a 3x. These two terms are going to give minus 6xy squared, and then this minus 11/15 stays the same. Okay, so that's it. Next one is negative a squared plus 18ab minus 2b squared plus 14a squared minus 12ab minus b squared. Okay, you get all that? Good. Okay, well, a lot of terms there, but let's just see. A squared and 14 is going to give 13a squared. Okay, 18ab minus 12ab is going to be 6ab. And then negative 2b and negative b is minus 3b squared. So that's like terms. 6 terms become 3 terms. Okay. Okay, now let's go to 26, where the objective here is to add them. Once again, we've already been doing this for quite a while, manipulating terms on, oh, well, maybe actually we were manipulating terms with actual numbers, but I thought we were doing it with these also, like when we had to solve these equations. Okay, 8x squared plus 9x minus 7. So you could actually line these up one onto the other one, but what I'm going to simply do is do it the way I did it before. That's 10x squared plus 13x minus 14. Okay? Six x squared plus 5x plus 7. Now this says and, but of course and is the same as plus. They shouldn't be putting and in the math book. That belongs in a word problem. X squared plus 6x minus 3. Okay? That's 7x squared plus 11x plus 4. Okay. Next one is negative 2x squared plus 3x minus 9. And here now they're expressing it in a different form. And they're putting 2x minus 3. So we're here, we'll just go down vertically. Minus 2x squared. 3 plus 2 is 5. Negative 9 and negative 3 is negative 12. Okay? Now, it's quite possible I might make a mistake by just going through these too fast. But if you do find a mistake, please add a comment on the video, and I will look over and check for comments, and I will, on a subsequent video, I will make the correction, Or if I think I was correct and that you are wrong, then I'll also talk about that. Okay? Okay, now this one is minus 9xyz minus 3x plus y plus 2. And I had to write that small. Okay. So those cancel. In other words, cancel usually just x now. Okay. 4x and negative 3x. That's going to give us an x. Y, negative y, that cancels. And we're left with a 2. So it's really just x plus 2. That's what we call a great simplification. Okay. The next one says subtract 13x squared plus x squared y minus 1/4 from 3x squared minus 4x squared y minus 1/4. Okay, so we start with this and we subtract this from. So 3 minus 13, negative 10 x squared. Negative 4x squared y minus x squared y is negative 5x squared y. Negative 1/4 minus negative 1/4. Now, that's going to be 0 because any two numbers, when you subtract one from the other, you're going to get 0, whether they're positive or negative. Okay, those cancel each other. So this is the answer. Okay. Okay, on to 46. Mixed bracket, perform the indicated operations and simplify. Okay? Minus 5 y squared minus 2y plus 4 plus 3y plus 7. Okay, so simplify and do this. So we're just going to go through them just like we did on all the other ones. Minus 5y squared plus y, because plus 3 and minus 2, plus 11. Okay? This is just exercising our mind. 8x to the 4th plus, minus 14x squared plus x plus 6 plus negative 12 x to the 8, hold on, 6. Couldn't see that very good. Minus 21x to the 4th minus 9x squared. Okay? 8x to the 4th minus 21. So what's that going to come out to? Minus 13x to the 4th. 21 minus 8 is 13. Okay? Because 8 plus 3 is 11, but we keep the negative sign because the 21 is bigger. Okay? Next. X squared and x squared. So here we have to keep track of all these terms. Let's go like this to indicate that we've already done those, okay? X to the 4th doesn't combine with anything, so we'll just go like that, okay? Now x doesn't combine with, there's no simplification there either, so we'll just x that out, okay? Oh, what am I talking about? Now I see negative 14x squared does combine with negative 9. So I'm going to have to make a correction. That's going to be 23. Okay, a negative 14 and a negative 9. It's going to be a negative 23. Okay, my apologies. Okay, but I did catch myself. Now there's going to be, I notice a negative 12x to the 6th. I'm just going to put that on the front. And I'm going to put the 6 on the back, just so I get everything in what I would call the conventional order. Okay, but in this particular case, I'm not sure if they're going to mark off for not having the correct order. As far as I know, they didn't ask for that. But if I were simplifying a polynomial, I would put them in order because that's just the way I do it. Okay. It could be in ascending order or decreasing order. Wouldn't matter to me. Okay, the next one. 4x minus 4 minus negative x negative 4. Okay, now before proceeding with this, it might help to do a little simplification simply by turning this to a plus, turning that to a plus, and turning that to a plus. So we don't have to deal with as many negatives in our head. Okay, so now it's easier. 4x plus x is 5x. Negative 4 plus 4 is 0. The answer is 5x. And that's 52. And wow, we're done. Because I'm going to say that in 52, well, we're only doing the even numbers, but still 52 in 20 minutes. That's faster than we usually have made progress on this course. So I will say that I had a very nice strawberry rhubarb pie. Tonight. I got it for Father's Day, and it tasted very good. So I just wanted to say thank you for the pie. Okay? So that's all for today.